So my name is Chenhui Li. I'm a postdoc at the University of Missouri. Today's topic will be the linking above ground and below ground ecosystem response to simulated drought in the reconstructed tall grass prairie. A little bit of my background. I'm from China. I did my degree at Texas Tech. So it's a red reader, now it's a tiger. My research interest is soil microbial ecology and chemistry, with a specific emphasis on exploring interactions soil microbial community with other ecosystem components and the response of microbial community to the global changes. The ultimate goal is to optimizing the soil functions to benefit the ecosystem and humankind, such as improve soil organic matter, stabilization, sequence carbon, and improve soil health. Terrestrial ecosystem, just like an iceberg, they hide most of their mass below the surface, which you can see from the carbon stock distribution. The organic carbon stock in the soil surface, 3 meter surface has almost 4 times carbon stock in atmosphere, adding organic carbon in the soil. About 5 to 6 times our biotic carbon stock above ground. Also, soil is the most diverse ecosystem, which you can see from this list, how much soil can support the organisms. In terms of numbers, bacteria is the most abundant group, followed by the fungi. In terms with respect of mass, fungi is the most abundant, and then bacteria. Besides all those organisms, soil also delivers all kinds of functions related to human life, people's life from every aspect. Includes provide food, fibers, fuel, and mitigate climate, provide habitat to all the organisms, as well as provide some pharmaceutical and genetics resource. Most of the antibiotics is from the soil. So even some scientists estimate that 90% of soil functions are affected by microbes. So which basically means that some microbes are everywhere and everything. Soil health is defined as a continued capacity of soil to function as a widely living system. 4 soil health management principles were proposed by RCS: year-round ground cover, living roots, less disturbance, as well as mixture of vegetation. All those management will simulate soil microbial community from abundance, diverse, and active. The simulated soil microbial community will improve all kinds of soil process, such as improve soil fertility, increase organic matter, and eventually will increase the soil functions, include enhancing plant productivity, prevent soil erosion, and improve the water air qualities. My doctoral research was soil health and carbon sequestration in conservation reserve programs here on the southern pipeline of Texas. The background of this study was that the wind erosion is a very serious environmental issues in the southern pipeline. You can see from this estimated wind erosion rate, the red part is southern pipeline. A picture from 2001 This is from the Textech campus. So the CRP project program is a 10 to 15 years contract between the farmers, producers with the government, convert the highly erodible agricultural land to the less disturbed perennial vegetative cover. In the southern Hampton, it's grassland. The CRP meets all those soil health principles, enhance the ecosystem functions. One of the topics of my doctoral research is to look at the carbon sequestration on the long-term CRP program. We look at the carbon sequestration from 3 carbon pools, more stable carbon pool, so organic carbon, and a little active labile carbon pool with particular organic matter, hot carbon, and microbial biomass carbon. We use the multiple regression with 3 predictors, CRP restoration years, the soil clay silt contact, and the precipitation. The main goal was to look at how the carbon stock changes along the CRP, along the increasing CRP years. But even though we try to minimize all the variation between the sites, we have total 26 sites. We try to target it on the same soil series, which was on the riddle soil, the benchmark of soil on the South Hampton. But still there's some variation in the soil texture. And we have 26 sites all spread out on southern Hampton, so it's a huge area. There's a little bit variation in the precipitation also. So this pie chart demonstrated show that variation is explained by each predictors. The green part was by the CRP. So if we compare across the 3 carbon pools, you can see the impact of CRP on this carbons increased from organic carbon, farm carbon, to microbial biomass carbon. So the CRP restoration contributes the most to the microbial biomass carbon accumulation. This result is consistent with the new organic matter formation, the microbial biomass-driven organic matter formation. The basic idea is the organic matter started with plant organic matter from photosynthesis, and then it will need to go through a microbial metabolic process. And the microbial microorganisms will eventually transform into organic matter and stable organic matter, organic carbon. So next question we asked which microbial group involved in this microbial decomposition process. We look at the soil microbial community composition changes over the 28 years CRP restoration. There's an interesting finding that the total fungi to bacteria ratio and the vascular mycorrhizal fungi, AMAT fungi to bacteria ratio has this bell shape across along the CRP restoration years. Those ratios increased from beginning to about 15 years and then decline afterwards. So to explain this trend, we look at plant immunity. The very old CRP site was only seeded by 1 grasses, but others is seeded by a mixture of mostly native grasses. So it started with different plant community. And also from a plant community session, as a survey in 2012, we found that the basal cover also show the little bell shape. The basal cover is the only the portion of the plant only extended to the soil compared to the canopy cover and the folio cover. The basal cover is less sensitive to the environment, can present the ecosystem more better. So the most dominant species were side oats grama and blue grama, even show more remarkable or noticeable this bell shape. Beside the plant community, there are also some other, there might also other inbiotic factors involved in this microbial community changes. The site, as I mentioned earlier, we only targeted one soil series, Amarillo, but you can see the soil clay series percentage varies from 50% up to almost 45%. And with the old CRP has the most sandy soil. The total precipitation from 2011 to 2014. By the way, the experiment was conducted in 2012 and 2014. So the total precipitation, even you can, there's only tiny difference, like 200 millimeter in 4 years, but it doesn't necessarily mean that this small difference doesn't make a difference in the 30 years CRP project. So our conclusion is this bell-shaped fungi to bacteria ratio was a result of all the combination of plant, soil microbial community succession, seeding practice, soil texture, and the environment. Next question we asked, so this microbes community changes, then that this includes the microbial activity involved in this nutrient cycle. We evaluated 9 enzymes involving carbon, nitrogen, sulfur, phosphorus cycles. The regression, the multiple regression also conducted for the enzyme. The 30-year CRP enzyme activity predicted from the regression model. This is the 2012 data. The table, if I didn't show any data in that cells, it means if there was no significant difference. So in 2012, under the extreme drought condition, you can see all the 9 enzymes increased with CRP years. And at least one enzyme in each category increased with CRP. However, in 2014, when the soil moisture improved, the precipitation became a normal condition. Then, on the surface, carbon and second depth, carbon, nitrogen, sulfur, all did not show any significant difference on CRP. Probably due to the better moisture condition simulated the primary production. And the microbes was not limited to by the resource. However, you can still see the CRP show advantage in the phosphorus enzymes, which is very helpful for the semi-arid soil and with above calcium. So, as I mentioned earlier, again, CRP needs all the 4 soil health management principles. The year-round ground cover will provide more residue input. And also, the year-round ground cover works like a canopy, reduce the diner temperature range. these figures, you can see that cropland has at both steps has almost double GTR, the dynamic range than the CRP and the rangeland. All those changes will increase the microbial biomass, energy biomass, and the community composition. Eventually, will increase the soil functions. So now we know that we need the living root together with our cover mixture of vegetation. All the plants they are important to the critical for the soil ecosystem, especially under extreme drought condition. But we still know a little, just know a little about how the plant and soil community interact in response to extreme drought. That's why we need our EPSCoR project, which is to quantify simulated drought of average or drought in a reconstructed tallgrass prairie located in central Missouri. Native prairie plant growth and diversity. Also, soil microbial ecology and soil microbial function. It's very well known that above ground, below ground interaction works as driver of system process. The plant community serves as determinant of soil community, influence the soil decomposer by the quality and quantity of plant residues. Provide accessibility of soil resource to the organisms, to the soil organisms, especially for those microbes has a symbiotic relationship with plants. The soil biotic interaction with that drivers of system profit. The soil decomposers provide nutrients to the plant and mediate a whole nutrient cycling ecosystem. The soil root associated the organisms is it's beneficial to the plant, like legumes, or they can be plant pathogens. Soil biotic interactions all kind of functions like carbon dynamics and the global changes. The extreme climate event like drought may have important consequences on the plant community and the soil community through this hierarchy levels up to ecosystem, community, and down to populations. So our first objective is to look at the plant community. That's the plant community change over time on the simulated drought in terms of homology, population dynamics, and physiology. That's the initial plant community composition for resistance to drought events. If yes, how? Second, we look at soil microbial community in the residence field and bulk soil. First, we look at how much microbes there. We can use phospholipiid fatty acid as a proxy of biomass. And then we can use, we use phospholipid fatty acid, we just short it as pillar. So we use pillar and look at the relative amounts of each group, general group, like bacteria, the gram-negative bacteria, gram-positive bacteria, and even fungi. Then we can also look at the specific composition, microbial community composition and structures using the high throughput sequencing to look at the bacteria and the fungi community. Now we know how much microbes are there and who are there, and then eventually we also want to know what's the function they provide, activities. So we can look at enzyme activity in all the carbon, nitrogen, phosphorus, sulfur cycles. In addition, we can look at the interactions between the plants and the microbial communities. So we can look at which plant species are more resistant to the drought in terms of their rhizosphere microbes. So we can look at all different plant species, compare plant species, and then we can look at regardless of plant species, we can look at which group of microbes they respond to the drought better or less ideal. To do that, we have a rain shelter structure built at the University of Missouri Bradford Research Center. Full rain shelter will located as the image shows, and the full ambient control will located just beside this nearby the rain shelter. The precipitation reduction treatment so far we use the DroughtNet online tool to calculate the first quantile and 10th quantile last 100 years in annual precipitation. At this particular location, it's 59% and 71% of return, precipitation return. Two controls, which means 100%, no reduction. One located in under structure, one is ambient control. Outside of structure. So under each structure, we have 3 plots co-located. In each structure, we will randomize the locations. The ambient control will be outside. So what we have done is in this summer, we collected the plant and soil samples. Plant community composition was conducted use of 1 by 1 meter contour. The plant species showed a block level variation, but all the plots were dominated by, in general, goldenrod, ash flower, native sunflower, and cow plant. We also look at a total of background biomass with a 10 centimeter transect at each plot. The soil samples were collected for baseline analysis, include physical, chemical, biological properties. And then we initiated the hoop house construction. All the daily corridors have been installed. This is drawn pictures. So, and also 50 centimeter plastic film have tarantula for the hydrology isolation. We also, this 50 centimeter was decided based on the clay pad depth. The maximum clay pad depth was 40 centimeter at that location. So we still need to do is to finish hoop house construction this winter, and electricity installation, irrigation system fit out, and we will start this 2-year precipitation reduction from next spring. That's all. Thank you, everyone, and I will take questions, comments.